Welcome back, guys. In this video we are going to continue our problem, which is the quarter car model, but this time in S domain. So let's get started. These are the equation of motion of the quarter car model from the previous video. By balancing MC, we have the equation mcyc double dot plus c1yc dot plus k1yc. By balancing MS, we have the equation msys double dot plus c1ys dot plus k1 or k2 plus k1 times ys equals to c1yc dot plus k1yc plus k2 times the input x. So we need to take Laplace transformation of both equations. So I want you to pause the video and start typing equation of motions in S domain and compare them with my equations. Welcome back, guys. So the equation of motions in S domain are yc over ys equals to c1s plus k1 over mcs squared plus c1s plus k1. The second equation, ys equals to yc times c1s plus k1 over ms s squared plus c1s plus k1 plus k2 plus x times k2 times mss squared plus c1s plus k1 plus k2. So in order to model this system, I will add three transfer functions. The first transfer function is this function, and by multiplying this transfer function times the signal ys, we will have yc, or the response of the chassis. We can take the response of the chassis and multiply it again by this transfer function, add them to the input x times this transfer function, and this will produce ys, which will be fed to produce yc, and so on. So let's see this on the Simulink. I've created a new model. So let's add the different blocks from block library. From continuous, I will add transfer function. Right click, add to untitled. From commonly used blocks, I will add sum. And I will add scoop. And from sources, I will add step function. We have three transfer functions, so I will copy this transfer function 3 times. And I will show the response of the chassis and the suspension system, so I will copy scoop block twice. Remember that I have this M file which contains the values of the different parameters MC, MS, K1, C1, K2. First of all, I will wire this transfer function to the scoop block. So this is yc. This is the transfer function c1s plus k1 over mcs squared plus c1s plus k1. So double click. The numerator is c1 and k1. The denominator is MC, C1, K1. Okay. So now we have added the transfer function C1s plus K1 over MCS squared plus C1 plus SK1. This signal is YC, so I will feed this signal back and multiply it to another transfer function. But first I need to flip this block. Flip. When you look at the second equation, you will see that yc is multiplied by this transfer function c1, k1, denominator ms, C1, K1 plus K2 inside brackets. Okay. I'll move this here and this one here. I will move the summation block here. The step input, which is x, is multiplied to the transfer function, which is K2 numerator over the denominator ms C1 K1 plus K2. I will arrange my model and expand this. Move this here. Where is the signal here? I will delete this one. And where is the signal here? So the input x is multiplied by this transfer function. Yc is multiplied by this transfer function. And they are added together here to produce ys. Ys now is multiplied by this block to produce yc. And I have added a scoop to plot the signal of yc. And from this scoop, I can take a signal from here to plot ys. Now my model is ready and I have set the different values of these variables, so I can run my model. The time here is 10 seconds, so run. Let's see the response of the suspension movement. This is the response. As you can see, I have some oscillations until damped. And this is the response of the chassis. Again, it's up to 1.4. I have forgot to set the step input to 30 millimeters. So run again. So now it's up to almost 45. And then the movement is damped. We can decrease the value of the number, make it 6 for example, and run. Back to our model and run. Now the oscillation, as you can see, are increased because we have reduced the damping coefficient. And this is the response of the chassis. You can actually compare the results from using transfer function to the results from modeling in time domain, as I have mentioned in the video of modeling the spring damper system. Thank you guys for watching and see you in the next video.